Alright, hi everybody. So today for our support lesson, we're just going to talk about Desmos a little bit. So talk about some of the things that we can do with Desmos. Particularly in our class, this has been a really important piece of technology for us in running a lot of these calculations and looking at graphs. So we're just going to touch on a few of the things that maybe you've forgotten about over the course of the semester, and some things that we've seen more recently. Hopefully this will help you get a more comprehensive idea of what's going on with Desmos. As always, if you have more questions beyond this, you're more than welcome to bring those to my attention, and we can go through any of this stuff on a Zoom meeting or via email, anything like that. We can talk about how to use Desmos and how to incorporate it. So to start us off, most of the work that we're going to do with Desmos involves a data set. So we need to create a data set first. So to create a data set, we just need to assign it a letter. So I'm going to just call it A. And then we're going to use square brackets. So we're going to use square brackets and input all of the data that we have. So this could be given to us in a problem, right, in a table. This could be data we gather ourselves. So I'm just going to put in a bunch of sample data here, all just fairly low numbers, fairly easy numbers. You're welcome to follow along if you want to try this on your own, or you can make up your own. So I'm just going to put a bunch, let's see, put a few ones in here, a couple twos, a bunch of threes. Let's get 4, put a 5, 5, 5, 6, 7, 7, 9, 11, and 16. I'll put another 11 in there. And I'll take out, just want to have a nice 20 element set. So I'll take out another one. So we got 1, 1, 2, 2, 3, 3, 3, 3, 3, 3, 5, 5, 5, 6, 7, 7, 9, 11, 11, and 16. Okay, and then I'll close that off. So Desmos recognizes that this is a list of 20 elements. So now we can do a lot of different things with this list. So if you are getting more proficient with the typing aspect of it, you can just type these things directly into the box here. But if you want to look for the functions, go down to the keypad here, or if you're doing it on your phone, the keypad is already pulled up there. So pull up in the keypad and then go to functions. And then up here, the two main ones we're going to use in this class are stats and dist. So stats and distributions. So let's go to stats. So of course, some of the things we need to be able to do are find means and standard deviations, right? Those are two of the big stats computations we do. So you can see here the mean button. So you can just click mean, or you can just type the word mean. So mean, and then it's mean of A. Okay, so you just put whatever your set name is in here, right? And you can call the set whatever you want, but it has to be the same letter. So it has to match, right? If I call this, A1, like that, now all of a sudden this doesn't recognize what A is anymore. Okay, so you have to make sure that the letter you use is the same. So that gives us the mean of A. If you want the standard deviation of A, that's this one right here. So that's STDEV. So standard deviation of A. So we have a mean of 5.3, standard deviation of about 3.9. You'll see another one on here that's just below it. So STDEVP, that's standard deviation of a population. If you go back and look in the earlier chapters, you'll see the computation is slightly different for a population versus a sample. Traditionally, though, we're going to use just the regular standard deviation for a sample, because that's most of what we deal with in this class, are samples. Okay. So there we have mean and standard deviation. Okay. We can also do some graphs with this. So I want to address this here. So first thing I want to do is I want to look at the box plot. So Let me get rid of these. So in order to do a box plot, and we're also going to do a 5-number summary. So in order to do the 5-number summary, so if you remember 5-number summary, that's going to be the min, the first quartile, second quartile, which is also the median, third quartile, and the max. So these values you can get also from here. So you'll see here there's min and max. But the nice thing about the quartile function is it can give you the min and the max as well. So let me just show you guys. So the min of A is 1, right? That's the smallest value. The max of A is 16, right? Because that's the largest value. But if we wanted to use the quartile setting, so quartile, just type that in there. Quartile of A. And the one nice thing that I really like about Desmos is if you try to type something in and it doesn't like it, it's going to give you this little symbol right here, and it's going to tell you what the problem might be. And that can really help when you're inputting things and you're not sure exactly how to type it. So this one says the function quartile requires 2 arguments. For example, try typing quartile of the set 1, 2, 3, comma 1. So what this is telling me is that it needs a data set, that's the 1, 2, 3 here, but it also needs me to tell it which quartile we're working in. Okay, so I have the data set A, and I'm going to pick the first quartile. So that tells us the first quartile of this data set is 3. I can get the second quartile, which is the median, right, the middle. So that's 4. I can get the third quartile, that's 7. And like I mentioned with the max and the min, if I pick, right, the one before the first quartile, that would be 0. That's the min. Okay, and then past the third quartile, that would be the fourth. That's 16. So we can use this to actually get our 5-number summary really quickly. Just have your data set right up here, and then type quartile of the data set, and then you can just go 0, and then, if you're writing this down, right, 0, input it, 1, input it, 2, input, 3, input, 4, input. And now that is your 5-number summary. Okay, so that gets you all of the values you need for that. And then if we want to create a box plot, here we go to the distribution, and then right up here is box plot. Okay, or you can just literally type the word box plot. Okay, so you can just type in box plot. Okay, and it tells you right here, enter the data set. So that our data set, we called it A. And right there is our box plot. Okay, and I mentioned this back when we actually studied box plots. Let me put projector mode on here. Back when we actually studied box plots, I mentioned that Desmos doesn't take into account any potential outliers, right? That's something we would need to compute for ourselves, because just by looking at this, it looks like 16 might be an outlier, just based on how far away it is from most of the rest of the data, but that's okay. So Desmos just gives you the straight up box plot, and then it would be our job to determine if there are outliers. When we hand draw the graph, then we would just go ahead and make that adjustment, right? We could put the star on 16 and then move this bar down to, I guess 11 would be the next value, if that was in fact an outlier. Okay, so that's our box plot function. You guys know you can change the color on any of these, right? You can make it whatever color you want. Yeah, and I have projector mode on. You can see their cool new feature. I didn't really show you this in class, but you can do reverse contrast. I think that's kind of fun, right? So you can play around with all kinds of different colors on here. Anyways, so let me go ahead and put this back. Okay, so that's 5-number summary and box plots. Another thing that we are able to do is, of course, the histogram. So again, this is under functions, under distributions. It's right up here, histogram. So we can just type in histogram of the data set. So notice it gives us the data set and the bin width are the two things we need. So the data set is A, and if not specified, Desmos will give you a bin width of 1. And the bin width is the class size, the class width. So, and then Desmos has a few features you can set here. So you can do it just by count. So the bar height, right, because if we're looking at 1, there's 2 1s in the set, there's 2 2s, there's 6 3s, there's 0 4s, etc., etc. Or you can do it relative, okay, which when we say relative, that means all of these values are just portions of the whole. So that means the sum of all of these individual areas add up to 1, okay, because that would be 100% of the data. Okay, so these would represent portions of the whole, but I'm just going to go based on count because it's a little easier to see. Okay, and then you can align them either center or left, okay, depending on how you want to work with it. Okay, bin width of 1 on a data set like this is fine. If we had a different data set, so I call it B, and we had 1, 1.1, 1.15, 1.26, 1.3, 1.35, 1.6, something like that. So there's a 7-element set, and I do histogram of B. Well, that's not as informative, right? Because all of my data points are really tight together in this range. So what I would probably want to do is make my bin width smaller, right? So we can see that all these values are within 0.6 of each other. So let me just do a bin width of 0.1. And now you can see right here, that's a little bit of a clearer picture, right, of what's actually happening in this histogram. So you can play around with bin widths as much as you want, just whatever makes the graph look a little nicer, gives you a better picture of the data. You don't want to have it be too small because then everything's going to look really spread out, right? If I spread this really thin, right, that's not really that helpful. But if you have it too big, right, if I just had 1 or even just 2, now it's just a single rectangle at this point, so that's not very helpful. Okay, so like for this data set, this histogram, right, maybe if I make the bin width 2, right, that's looking a little better, right? That gives me kind of a better picture of what's happening here. We can talk about the shape of the graph. This one looks to be right skewed, right, because the tail is on the right over here. So a lot of different things we can talk about and look at in the histogram, okay, when we're looking at approximating curves. Okay, all right, so that's the histogram. So let's see, what else here do I want to talk about? So I definitely want to talk about the normal curves and the t-distribution. I'll mention the permutation combinations. So we did a little bit of this, earlier on in the semester when we were talking about probabilities, but you can compute permutations and combinations of this. So you can see, right, permutation combination, we have NPR as well. This tells me, N choose R, right? So if I have 5 objects, I'm choosing 2 of them. There are 10 ways that I can do that as a combination, right, where order doesn't matter or, labels don't matter. And as a permutation, if I do 5, choose 2, there are 20 ways to arrange them in a way that the order that they're put in actually makes a difference. So, so we saw those earlier in the semester, right, with factorials. You can also do factorials, right? So 5 factorial, right, that's 120, right? That's 5 times 4 times 3 times 2 times 1. So we can do stuff like that. So it's just some calculation stuff that you can work on as well. Okay, but let's go ahead and start looking at the normal curves now. So with the normal distribution, so we have normal distribution, and if we don't specify otherwise, Desmos is going to assume that our normal distribution is the standard normal distribution, so it has a mean of 0, standard deviation of 1, like it says right here, okay, unless we specify otherwise. So if we're working with a data set like what is ours? Actually, I can just put it directly into here instead of typing it separately. I'm going to use mean of A and standard deviation of A. Those are going to give me my mean and my standard deviation. So you can see this curve is much more spread out. If you want to look at it a little more clearly, we can go ahead and tweak the dimensions on the x and y axis. So this is under the graph settings here, the wrench. So the x-axis, I want this to go, well, I know all my data is from 0 to 16, right, or 1 to 16, I guess. But that curve's looking a little shallow still. Let me do 13. And then my y-axis, if I want to get a better look at this, I'm going to zoom my y in a lot. So y is going to go, actually I'll make it just slightly negative, negative 0.5 up to, say, 1. No, even smaller. Let's do positive 0.5. Like that. And then x, let's make that go a little wider there. Yeah, so that's a little bit of a better look at our curve. So you notice the scale is different here, but that's okay, because it tells us what the scale is, right? So we can just read it appropriately. So you can do normal distribution, input your mean and standard deviation, and then we can find the cumulative probability. So this one really helps us when finding the probabilities, the area under the curve, right? The p-value when we run these tests. And you just tell it either what the min or the max is, right? So if we want this to be, everything above, say 7, right? That's 0.332 approximately. So that tells me that if we were to randomly select a number from this set, the probability that it would be above 7 is about 33%. Right? Or if I want to change that and I say, well, what's the probability that the number is less than 7? Well, that's everything to the left here, so that's about 67%. Right? And if you take those two together, right, that's just 100%. That's all the data there. So that's our normal distribution. We can also find corresponding z-scores by using the inverse CDF function on here. Okay, so but what we have to do first, and this is where it got a little tricky, but you have to put a period there first and then put inverse CDF. Okay, and this allows you to tell the the function what area you want to the left. So let me just move this down here so we can still look at the graph. So let's say I'm looking at, 7, for example. I can tell it I want to stop at 7, and it tells me the area. What we're doing with the inverse CDF function is saying, here's the area to the left. Now you tell me what the z-score is, or what that coordinate is. Okay, so like for example, this number, 0.6682 approximately, that came because I knew that I wanted to look to the left of 7. But if I didn't know that it was 7, and let's say I want to figure out what that coordinate is, where the area to the left of it is 0.6682 approximately, right, you can see that this number is getting really close to 7 right here, right, 6.999, right? So you can use the inverse CDF function, give it an area to the left, and it'll give you the z-score. Okay, so that's how we can identify z-scores. That's also how we do like z sub alpha, that kind of thing. So if alpha is 0.05, right, so I want 5% of the data to the right of alpha, then I would say I want 0.95%, or excuse me, 0.95, right, 95% of the data to the left of alpha. So I would just put 0.95, and that would tell me my z-score for alpha would be about 11.7. Okay, and that's if we're running these tests that we've seen in the last couple of chapters. We can also do the t-distribution, so that's t-dist right here. And t-distribution, all we need from this is the degrees of freedom. So whatever that may be from the problem, right? So 15, something like that. This gives us our t distribution, right? And you can notice that as the degrees of freedom shrink, right? 5, 4, 3, 2, 1, that the curve starts to get smaller. But if we have a high amount of degrees of freedom, it really starts to round out. So you can see that's kind of the max where we're looking there. Okay, but then we can look at the cumulative probability, right? And again, this one is more for when you're running tests. Okay, this is with samples. That's why we use degrees of freedom in it instead of just, right, the population mean and standard deviation. And then you can also run inverse CDF on this one as well. So, and I could do, 0.95, whatever I want, to get that t-score in this case. So I think that just about covers a lot of the stuff that we've seen so far in the course. So we've got a lot of the computational side of things. We've got some of the distribution stuff that we've done. So, if there's anything else, again, that you have a question on, that you are, still a little uncertain of when it comes to typing things on Desmos, or anything maybe I didn't mention that you're wondering about, please let me know. I'm happy to go through any of that stuff with you guys, either in another video or a Zoom meeting, anything like that. So hope this was helpful, and I will talk with you all very soon.